By the way, if you want to have access to these slides, you can get it now in this URL, bit.ly/Kubernetes intro. Okay, you can think about it just like open source slides. So if you see something interesting, you can just grab the specific thing that you saw, or you can grab everything. There's no copyright, okay, so just get it. So this talk will be about Kubernetes. It's an introduction to Kubernetes for those who are already a Docker user, or for those who are just developers and want to start using containers and go to production. My name is Rafael Benevides. I work for Red Hat as a director of developer experience, but essentially I'm a Java developer. Okay, so we are talking developer to developers. But before starting talking about Kubernetes, let me talk about the Red Hat Developers Program just briefly. I just want you to know that this program exists, where you go to this website, developers.redhat.com, and you can get free resources for us, for developers, like ebooks, webinars, blog posts. There are some interesting books like Migrating to Microservice Database, Introducing ISTO Service Mesh for Microservices. And also, since we are in a Java conference, I cannot forget to say about the microprofile specification. So if you want to produce microservices using a specification close to what it was Java EE, now Jakarta EE, you can use microprofile. Just visit microprofile.io. Okay. Well, so we are all Java developers, right? We all know that Java is portable among different machines, as long as you have the Java virtual machine, the JVM, right? So what would be one of the reasons that you decide to place your Java application inside a container? Why we want to get our Java application and run it inside a container, since it's already portable? Any suggestions?
Consistent environment.
Perfect, consistent environment. Yeah, sandbox. Okay. Sorry? Easy to maintain and scale. Yeah, those are some great points. When we have a lot of advantages, we saw some advantages here when we mentioned when we adopt container, right? It's lightweight, it's fast, it's easy to scale, simplify our DevOps practices, encourage microservice architecture, provides isolation, right? So we have a lot of advantages. And what we do when we want to run a container? By the way, who have used Docker here? Okay, so you are all familiar with this comment, right? If you want to run a single container, what we do? We type Docker run, unless we are using Docker Compose, for example. But usually it's Docker run -d to create a detached process and the name of an image, right? But that creates only a single container running on a single machine. But what happens if we have, like, here I have 6 servers, but imagine that we have 10 servers or 100 servers. We will face, of course, some challenges, like, for example, how to scale, how to avoid port conflicts, right? How to manage them in multiple hosts. How do we know that the container is still running? How do we update them from the version 1.0 to the 2.0? Where are my containers? So those are the kind of challenges that we face when we decide to go to use more than one container in more than one single node or server. And for that purpose, there is Kubernetes. Who ever tried Kubernetes here before? Okay, that's good because my idea here is to do an introduction of Kubernetes for those who have never used. Okay, Kubernetes is an open source project written in Go. It's very, very popular. You can see that by going to the GitHub page, where you see a great number of commits, stars and contributors, more than 2,000 contributors. And between these contributors, I can mention Red Hat Core OS, which was bought by Red Hat, HP, Pivotal, IBM. So it's a product that's only not supported by Google, although it was created by Google. Okay, but let's see how that works. Kubernetes can run containers inside what they call nodes. They don't call it servers because you can run that node in a physical server, on a virtual server, or in a cloud, private or public, okay? And then, for example, you can see here that there are some Tomcats here, there are some databases like Postgres and MySQL, and one container can connect to another container in another host because it runs on a software-defined network, okay? And they find each other using a service layer. I will explain what is a service layer during this talk. Of course, we all know that containers are ephemeral. If the container dies, everything inside the container will be lost. So Kubernetes is prepared for that. So it has a support for a persistent storage. And to manage, by the way, to access those containers here, you have a routing layer on the top that allows external devices to access those containers. And to manage everything, you have one or more masters, right? Because if you have just one, you have no one, right? We need, so Kubernetes is prepared also for a cluster inside it. It's made for developers and for admins. We'll see more of that. When I started learning Kubernetes, I came from Docker, and I was, okay, I have an image, the image creates a container. But when I started learning Docker, I saw different concepts. I saw pods, services, replication controllers, replica sets, labels, and I was like, what? And then I figured out that among all those Kubernetes objects, if I learn these 4 concepts, I can learn everything about Kubernetes. Okay, these are the 4 concepts that we need to know: pod, replication controller, service, and label. So we'll do a short trip on these concepts, and then later we'll see how that works on a demo that you can access if you are connected to the Wi-Fi. Okay, the first concept is a pod. I was like trying to understand what is a pod, and pod just made sense to me when I learned that pod in English is a collection of whales. It's the collective of whales, and whale is the logo of Docker. So a pod is a collection of containers. It's a group of containers. So sometimes your application, your 2 or more containers need to walk together in the cluster. That's one of the reasons that we'll place more than one container in a pod. There's the case of Service Mesh. We have a talk today from Nicholas that he will talk about Istio. A little bit, right? A little bit about Istio, which is a Service Mesh implementation. Or, for example, you can run your application plus an administrative console plus a log collector. And when you place your containers inside a pod, you share IP, secrets, labels, and volumes. We'll see what are labels and volumes later. To define a pod, you can create a YAML, and every YAML in Kubernetes is very similar. You have a header, which says the API version. the type of the object, in this case the kind is a pod, the metadata, so you can place the name of the pod plus the labels, and the specification, which is the name of the container plus the image, and so on. That will create this pod here. What else we have in Kubernetes? So imagine this situation. We have these applications running inside our cluster. Note here that we have 4 Tomcats, okay, one there and the other there, and suddenly something went wrong. The application, the node crashes, the node dies. What happened to those containers? Well, those containers will be migrated, started again in other nodes. That's the paper of replication controllers / deployment. It used to be just a replication controller that controls the number of replicas, but then call it deployment. The deployment just for the configuration, and if you change something, if you change the container name, if you change the environment variable, memory limit, anything that you change in the specification, it will redeploy all those containers that it managed. That's why it's called deployment now, and not only replication controllers. To specify, you just have a deployment, the name, and the specification, the number of replicas. And note here that the template that the deployment creates is just like the specification of the pod. So you have the metadata section and the specification of pods. Okay, it will be clear, much more clear when we start deploying our containers in a cluster. We have also labels, and by the way, everything inside Kubernetes have labels. Okay, so nodes, volumes, pods, services, replication controllers, deployments, everything can have labels. And labels can be used to find a specific object inside a cluster. So imagine here, we have 4 wildflies deployed. Each one of them have different labels. So imagine that I want to find everything where my application has the label app. Cool, I'll find those 4 applications. Everything that's running on a development environment, everything that's running on production, everything that is running the version 1.0, everything that's running the version 2.0. So that's what are labels for. You can find objects inside a cluster. And labels are just key value pairs. It's inside every YAML definition, you can place those key pair values, and that will create a label. And labels can be used for services. So remember when I said that a container can die and Kubernetes will start the container in another node? Of course, the container every time will have a different IP. So we never connect directly to a pod. We need to connect to a service. Service is like an internal load balancer for Kubernetes. And it uses labels to find what pods it should connect. So here I have 3 pods. But my service will connect only to the Wildfly application because the label selector matches app cool and environment prod. My other application will not be part of this load balancer, okay? And to define a service, again, you give a name, you give you say that it's a service, you give a name, you specify the target and destination ports, and plus the selectors. Okay. The good thing about using services is because you gain for free a service scope. Remember the architecture of Kubernetes, where I said that there is a software-defined network. Inside this software-defined network, there is a DNS, internal DNS. So when you deploy a service called MySQL, for example, you gain, every other container will have environment variables just like this, MySQL port 3306, the protocol, the host, or you can just use the internal DNS and ping by its name. I'll show that to you. Well, related to persistent volumes and rolling updates. Persistent volumes can be managed by the admin and by the users. For example, for us, to the cluster, read write, means existed. Google Cloud Engine are the things that we don't manage as developers. It's managed by the admin. As a developer, we claim, and once that we claim a volume, we will receive a name, MySQL PVC, MySQL persistent volume claim. Then we can bind a volume mount to a specific path matching the name of the volume to the name of the claim. Okay, that's how you match, you make a pod to see a volume. Okay, we'll see more of that as well. And finally, another concept is when you have a version 1.0 for replicas, and you decide to update to 2.0. So when you request or when the deployment detects a change, it will perform a rolling update. It creates a new replication controller for that version, and it starts rolling. It starts a new container. So now I have 5 replicas. If this pod lives, it will reduce the number of replicas on the version 1.0 to 3 and start a new one on the version 2.0. And it will keep doing that, and all the connections will be redirected to this new pod, so we will always have the service available during an update until the last version when the connection, when the replication will be removed. And finally, you will have everything running on the version 2.0. Okay, so let's see those things work. Those are the basic concepts of Kubernetes. What we will see now is an application that has a front end written in Node.js. It's the only part that's non-Java here, that connects to a Vertex application. Vertex is a framework for reactive applications that uses Java. The guest book that will get and post message to MySQL. So we have a complete example with database, a front end, and 2 microservices. This is the screen. When you see it, and you will be able to access, when you click submit, it will post the message on the guestbook service. Then the guestbook service will retrieve the message from the database, and the hello world will be printed here. So let's see it. I will run kubectl get pod. See, we have 1 pod of MySQL running. If, just like Docker, when the log instead of doing Docker logs, I will kubectl is Kubernetes. So to get a log, you use kubectl logs and the name of the pod. That will bring to me. If I want to follow the log, I can, just like Docker or tail in Linux, I can use dash. That will keep following the logs, okay? If I want to execute a new process, just like as I do Docker exec, I can do kubectl then back. This pod has only one container. That's why just the name of very straightforward. Details of okay. Things here. Example. To starting the audio. Okay, perfect. So you see that you always connect to the service. So let's start playing. What happens if I want to deploy an image called Rafael slash microservice guest book? I would run this command, right? Docker run, I would give a name because it's a good practice to assign a name for a container. Guest book service. Let me copy and paste here. then the name of the image, and the tag of the image. To run a pod using Kubernetes, you just replace Docker run to kubectl run. The name is already the second parameter, and you specify the image. Of course, you can specify also the number of replicas. For example, suppose that I want 2 replicas. I just say it here, -r2. If I want to specify labels, I also can specify here in the kubectl command. Like for example, app equals guestbook, version equals 1.0, environment equals production. When I deploy that, it will say that the deployment was created. By the way, I just showed this command so you can see how it's very close, very related to Docker, for those who are familiar with Docker. But this command will be removed. You will have something similar with kubectl. You have something similar with kubectl create deployment. Deployment and everything else, it's the same parameter. Okay, I just want to show how it's very similar to Docker. Okay. By the way, let me open that inside OpenShift. OpenShift is shift. Okay. Oh, sorry. I'm running this cluster inside OpenShift. OpenShift is a platform as a service of Red Hat that runs on top of Kubernetes. So you saw that every command that I did here was with kubectl. Kubectl that create the run, kubectl get pods, kubectl get services. And look here what happened. Here I have my MySQL, the service, the IP address, the pods that connects to MySQL. I've created a deployment, which is also here. I specified some labels. Those labels are here: app guest, environment product, version 1.0. I specified 2 replicas. I have both replicas here. I can choose one pod and see the details of that pod, like metrics, logs. So it's much easier than typing commands, right? You have a terminal. By the way, remember what I said about service locator? The guestbook service needs to connect to MySQL. So I have 2 options here. I can do I can connect by environment variables. You can see here that MySQL service port, MySQL port, and other environment variables points to the cluster IP address, or I can use by name. If I ping MySQL, it will also return the same IP address of the service. Okay, let's continue. Let's keep doing that. You saw that I could deploy a container, use kubectl run, but that's not on the recommended way because it's not always reproducible, right? You need to specify environment variables by hand. If you need to mount volumes, you need to specify that. So it's better to use what? It's better to use a YAML file, just like I mentioned. So let's see one example of YAML file here for another microservice that we will deploy. The Hello World service vertex is specified in this deployment file. Here I also say that has two replicas, I have metadata. It will create a container called Hello World Serves Vertex using this image. It exposes this port. So it's preferable to have that. So you can store that YAML file inside a Git repository. In this case, it's in GitHub. And the good thing is that I can run kubectl create -f, specify that file straight from the GitHub, and it will run the deployment and create the deployment to me. So as you can see here, it's already creating. It's easier than just doing kubectl run or kubectl create deployment, etc. Now, what is the other file that we want? If we have two replicas, even if we have one replica, we need a service. By the way, I forgot when I talked about the guestbook service, I forgot to create an image for the guestbook service, right? So let me return, and to create a service by hand, I use kubectl expose my deployment. What's the name of my deployment? Guestbook service. And I need to specify what ports I will expose, the mapping. So it's 8080 to 8080. So that's how I create services by hand, kubectl expose. So you saw that when I ran this command, it created a service called guestbook service. To use the file, it's simple. I have the YAML file that defines the selector. Remember the selector, the target and destination port. I just use kubectl create -f and the name of the file. That created a service here also. So I showed you two different ways of creating objects inside Kubernetes, or running the command kubectl, or specifying the file. Specifying a file, it's the recommended way, because you have infrastructure as a code. You store, you track who changed it, when it was changed, why.
Git play. You mean git play?
Exactly, that's right. Okay. Since I showed to you how to use kubectl, I want to show to you also, and I showed the OpenShift console, I want to show to you a feature that only exists in OpenShift. Because, as I said, when you are running OpenShift, you are running Kubernetes. So OpenShift 3.11 runs on top of Kubernetes 3.11. But everything that we did so far, it had an image that I've created previously and I stored at Docker Hub. But what happens in this case here, I have one application and in my GitHub. I have the front end here that was created using Node.js. And I want to deploy that. I have an image, but I don't want to use the image because the image is outdated. I can come here to OpenShift and select Add Project, and I can specify, for example, different language, Java, JavaScript, Perl, Ruby, PHP. I have databases. I have the middleware part with integration, process, runtimes, and frameworks, CI/CD, etc. But in this case, it's an application written in Node.js. So I will select JavaScript, Node, and I can select different versions of Node.js. I will use the version 10, and the name of the application, I will call it front-end. The GitHub repo, I can inform here. And of course, inside this repo, I have several sources. I have the source of the guestbook service that uses Java. I have the source code of the Hello World service. So I need to specify what is the folder, the directory that contains the source code of this application, the front end. So I specified here. And I need also to expose this externally so you can try and access. So I'll give a specific name. I'll call it frontend dash app dot app. Let me dot app dot rafabene.com. So if you go to that address in a couple of minutes, you will see this application. Of course, I can specify how I will build my application, how I will deploy. I can give environment variables. The scaling will have only one replica, is manual. I could create automatic scaling, everything using a web console. So once that I create, you can see that it created for me a deployment, but I don't need to run Docker build manually. What it will do, it will check out the source code from that repository that I've specified. I said that it's a Node project. If it was a Java project, it would run a Maven package for me. But since it's a Node application, it will run npm install, which is just more or less the same thing. Then it will create an image. This is called source to image. I just give the source and OpenShift creates the image to me. And once that the image is created, it's ready, it will push that image to internal registry. And once that I have the image, you can see the image here, build image, the image of front end. It has already published. It was already published. It creates the container. And I can now open, you can also open this address and you should see the application. Let me refresh. Okay, it worked. So now you can say hi. So let's give a name, Rafael. Hi, Lviv. Let me submit. And there we go, it's working. Let's start playing here. I can, for example, delete this pod just to check if I will not lose the data. I will even delete the pod immediately. The MySQL is being created. Now let me refresh. Oh, the data is there. And someone even tested. So I'm not losing any data at all. Okay? And plus, another good thing about using source to image is that I can come here to the deployment and have, not the deployment, the build. I have the build for the front end. I can configure a GitHub webhook. So for example, if I'm here at this repository and add a webhook to this URL, to the URL that OpenShift gave me. Now let me disable, okay. If I modify something, let me modify here, index. Instead of say hi, I will say hi version 2. Commit this change. We should see a build number 3 starting. We don't need to do anything. You just saw it here. I just modified something on GitHub, and OpenShift takes care about creating the image, check out the source code, build a new image, and once that the image is ready, it will perform a rolling update that we saw. Just like here, And once that is ready, we should see version 2. Refresh. Oh, it's running on build number 3, sorry. But we will see that change in version 3. Okay, plus we have a lot of things that we can do like in the source to image world. Because, for example, I could deploy directly the image here with another name. Let me perform that. Let me give a name here. As I said, I have an outdated image deployed on Docker Hub. You can see that was created like 3 years ago. Let me deploy that image, and I will call it microservice frontend. Let's just refresh. Yes, say hi, version 2. Oops, where's my SQL? Oh, it's here.
That was scary.
Yeah, that was scary, especially in a live session. So here I have microservices, a new old image that I've deployed, deploying an image straight from this deploy image. And what I can do also is perform a kind of canary deployment by coming here and saying, I want to split the traffic between the front end that I've deployed from source code and the microservice front end that I've deployed from the image. And here I can control, for example, 10% of people will see the version v2. 9% of people will see the version v1, just like this one. This is another example of things that I can do with OpenShift. So if you try now, probably some of you will see the version 1, other will see version 2. Who is using the cell phone here to connect? Who is seeing with no version? Okay, you've seen no version. And who is seeing version 2? Okay, perfect. So that's one of examples. How can I control the routes and split the traffic between 2 different versions using OpenShift? That covers introduction of Kubernetes. So you solve from the scratch, from the basics, from the concepts, until deploying it on a cluster that's live that you can access. And if you have any other questions, please feel free to use this 1 minute that we have.